Hello everybody, this is a tutorial for my Year 12 Math Methods class. This is about inverses. This is the second one of inverses that I've made. Now in the previous one I guess I'd sort of done a few basic ones. Now this is a little bit more tricky. Okay, with this one the question is, what happens if we have to find the inverse of a parabola? And this is a more complicated type of problem. Now usually with inverses there are two parts. There is swapping the domain and range. Swap the domain and range over. And the second part is swapping x and y over. Now if we sort of look at each of these things, the problem is with this parabola it's hard to tell what's going on. Okay, so what about if we sort of look at this, and I'll put this part here, y equals x squared minus 2x plus 3. Now if we were to swap the x's and y's over, we'd end up with a y in two spots. That makes it very much more difficult. But what about if we complete the square? So if we have y equals x minus 1 squared plus 2. That's completing the square. So if we were to sketch that, we know that the turning point would be at 1, 2, up there. 1, 2. So it would be down like that and up like that. Now the problem is that we can't find the inverse of this, because if you're going to find the inverse of a function, it's got to be a one-to-one function. So we have two choices that we can make. We can say we can find the inverse of this part here by restricting the domain, or we can find the inverse of this part here also by restricting the domain. So there are two inverses. So if we were to say, alright, we're going to find the inverse of the red part, that would mean the domain would be from 1 up to infinity, and the range would be from 2 up to infinity. Now if we're going to find the domain and range of the inverse, the domain of the inverse would be from 2 to infinity, and the range of the inverse would be from 1 to infinity. And if we swap the x and the y over here, swap x and y, we'd end up with x is equal to y minus 1 squared plus 2. We could change that minus 2 across to the other side by changing it to minus 2. We'd take the square root of both sides, and that square root would get rid of that square here, so we'd end up with y minus 1, and we get y is equal to the square root of x minus 2 plus 1. So the inverse would be from 2 to infinity mapped on to 1 to infinity, and the inverse function would be x minus 2 plus 1. And that would be from over here, say at 2, 1, and it will go like that. And you can see how in the line y equals x there, that this part here would be a mirror image of this part here. Now there is also another inverse if you'd like. You can change the domain and range for the black part, this one here, from negative infinity up to 1, and from negative infinity up to 2. Now that'll affect the shape of the graph, and as a result also you'll end up with a different equation for the inverse. Alrighty, let's try another one. Now here we have to find the inverse of this. This is a hyperbola, but you might not recognize it at the moment. What we need to do is change it so that we can get the x's all in one spot. So if we say, well, this will be x plus 2 divided by 3x plus 7, and if we said, well, it goes in 3 times, x plus 2 goes in 3 times to 3x plus 7, and 3 times x is 3x, and 3 times 2 is 6. Then if we take them away from one another, 3x take away 3x is 0, and 7 take away 6 is 1. So 3x plus 2 3x plus 7 over x plus 2 is equal to 3 with a 1 remainder. So that if we wrote instead y equals 3 plus 1 over x plus 2, that looks much more like a hyperbola now. And what we can do is we can do the standard steps to change it into a inverse. So we'll need to swap the x and the y and swap the domain and range. Swap the domain and range and swap x and y. Now if we swap x and y here, if we start out with, and I'll use this expression here, 1 over x plus 2 plus 3, and we swap x and y, what we'll end up with is x is equal to y plus 2, and we've got to take that 3 across, so it'll be a minus 3. And what we'll do is we'll take that up to there, and that one down to there. So we'll end up with y plus 2 is equal to x minus 3, and I'll keep going from there. I'll say y is equal to x minus 3 minus 2. Now if we were to swap the domain and range, now the domain of this hyperbola could be all real numbers except for when x is equal to minus 2, because if we put in minus 2 we'll get 0 on the bottom of our fraction here and the fraction will be undefined. Now the range, well, the range is everything except 3. So all real numbers except for 3. Now if we were to try to figure out the domain of the inverse, it would be swapped over from the range of the original. So the range of the original would become the domain of the inverse, and the range of the inverse would become the domain of the original. Now that kind of makes sense, because if I try to sketch it there, and I sketch my original in blue, the asymptotes would be at minus 2 and at 3, and our graph would look like this. But if we were to find the inverse had an asymptote across here, that should be y. The inverse had an asymptote across here at x equals minus 3 and a horizontal asymptote y equals 2. Now it might not look like it, but this will be a nice, if we try to draw in a y equals x here, there'll be a nice mirror image of one another. Alrighty, well I hope that helped with inverses, and I'll see you in class.